Hey, and I am back. Okay, yes, it's up. Let's start talking. Alright, so Pascal's triangle. I have heard or seen this problem before. So the pattern is basically as it's showing in here. Every node is the sum of the two nodes directly above it. The outermost nodes are all 1. Generate the first. So I've given this input, generate output, which is literally like nothing to do. To do run for 5 rows. So let's make the outer loop for number of rows. And then number of elements is also equal to the row count. So the inner loop is going to be same. Create a new vector over here, which will be pushing to your result. Fairly straightforward. Probably will still fail because I suck at coding. Uh, Pointer index expression with base overflowed to, like I said, So first loop fails. Awesome. Okay, probably a different error this time. Hmm. So that is one. Okay, cool. Obviously fairly simple. Just if you're at the left or right end, just push one. Otherwise, push the sum of the um, push the sum of the. So if you look at this pattern at this angle, you will realize that this is equal to the every node is equal to the previous j and the same j in this line. So yeah, so take the previous j in the previous row and the jth value in the previous row, and that would be your new temp, new value. Cool. Okay, this was fairly simple and you know I think decent runtime. Let's okay, DP is one answer. I think this should be DP itself. Yeah, you don't even need to keep previous row, you can just get it directly. It is n square. Yep. Let's hope nobody's posted a. Yeah, not. Okay, cool. I'm sure this is gonna be a rascal. I think this is finding the value at any one node. Run the kth index of the Pascal's triangle. Yeah, so basically, if input is 3, then you return the third row directly and not uh, these. And could you optimize your algo to use only OK extra space? Oh, okay. So I've heard, so this is again n square, but OK with OK space. Um, let's just copy this. And the trick in this is, since you don't need all the values, and the current row depends only on the previous row, so why not just store the previous row? So So instead of pushing that to a previous row, we just add a previous row. Um, and did a semicolon after what? After brackets. Hmm. Hmm. So we're returning the one we one step behind basically. So if it was three, it returned this one, one, two, three, four, the fourth one. So basically, it's the question's fault and not ours. So this should be submitted correctly. And yeah, it works. The 8-4 is just the other issue. Um, yeah, this is what most people would be doing for sure. Um, I've heard there's also a formula for the Pascal's triangle. Mm, somewhere. Mm, yeah, here it is. Um, yeah, they say it's NCK. So either you calculate that, which is like calculating factorials, and yeah, I'm not sure what would be better. Maybe calculations would be a better option down the road, where you could be saving some values, some factorials. You could be saving. You could just calculate all the factorials and then just divide and multiply numbers. That might also work. Okay, cool. Best time to buy and sell stock. Okay, this is an array question. I'm guessing. Done something similar before. Say you have an array for which the ith element is the price of a given stock on a day. Oh, if you were only permitted to complete at most one transaction, that is buy one, sell one share of stock, design an algorithm to find the maximum profit. Know that you cannot sell a stock before you buy one. Oh, genius. If you buy on day 2 and sell on day 5, hmm. Okay, this is different from what I did, I think, but this also seems fairly simple. So, um, something that I can think of, I'm not sure if there's a solution without extra space, but something that I can think of is we store the index of the so we store the first index of the first element, and then if we find a smaller element, we store that number's index. Um, we empty the stack till we reach a place where the number that we found is greater than what's already at the top of the stack, and then we push our next number, and we keep on doing so till we find a number that is that is that is if it's greater than the number, then push it to the stack. If it's smaller than the top of the stack, then pop the top of the stack and push that number. That doesn't make sense because the end of the stack is now going to have a smaller number than a larger number. So, okay, let's skip that technique. Okay, let me start writing something down, and if it starts making sense to me, then I'll try and explain it to you. What I'm thinking of is, so I looked at this case which failed. So this is a proper decreasing sequence, right? So basically, in case, um, so say we're keeping a stack. In case your sequence is properly decreasing, means the stack would always have one or zero elements. Um, let's say one, if we're keeping the first element always inside the stack, and reducing it every time we see a smaller element. In that case, if the stack doesn't have two items at any time, the output would be zero. For the first case, we'll do the same. If we find a smaller number than the top of the stack, we remove that from we remove all the elements from our stack that are greater than that number, and then push that number in. And we push till we don't reach this case again, basically till our stack's in ascending order. So the smallest number will always be in the front of the stack and the bottom of the stack, sorry. And but the largest number won't always be at the top. So if we find a large number, we push it. If we find a smaller number now, we empty the stack, push that in, and then any larger number that we find, we push that in. So basically, we'll be comparing from the bottom of the stack to the top of the stack. So to check if we have access to the bottom of the stack, I'm going to need to refer this push back, pop back, back, empty, top. Access the topmost element. Underlying container. Hmm. Okay, so it does not seem like you can access the element at the front. How about a queue? So you do have access to both the first and the last element, and pop removes the first element. What if we need to remove the last element? So I guess let's keep array itself. Um, so I don't know how long this loop will last. Let's see. True. Okay, so not push this maybe. Um, it's just keep the index. So while a dot size is not equal to 0 and um, let's keep an index, I mean an iterator, um, and this number is larger than the number that we are currently on, which will be prices I t. Then the access modifier erase elements. Sure, we can use this. I'm sure this is not the best solution. This is just something that I thought of. We look at the best solution. We look at the solutions afterwards. If this works at all, that is anyway. Let's keep a max difference. Um, oh, you can't modify prices, can you? Do we have to? No. A dot erase this element, right? Or do we pass the index position? Okay. So we empty the stack as long as and then in either case, we be our condition. This would be our max difference. We can only check this if if A is not empty. So if A dot size is greater than 0, and then we return the max difference. No matching function to call this. So it's actually going to be A dot begin plus this, I guess. I was not declared in the scope. It was not. You are correct. Good, sir. Not a lot of chatting for a just chatting stream. My bad. Maybe I'm just tired. Okay, seem to have worked for this case. Okay, seem to have worked for all cases, which to my surprise is surprising. Sorry about not talking enough. I don't know why. I might have been too busy focusing on the question, which I will take care of. I will not. I will. I'll talk more. Okay. Okay. So, hmm. So it says. So you calculate the min price at every index and the max profit. Uh, oh, ah, what was the complexity of this one? My solution, this would probably be ON times something on the order of n square, I'm guessing, since the number of elements that you do add, you might have to take them all out, but you'll be taking them out only once. So it's going to be you're going to take out an element only once also. So it's going to be O2n, which is ON also. So that's fine. But there is a simpler logic, obviously. Um, this is something like a min price array, which is the minimum price that you found up to a point. So, for example, for this question, that would be 711111, and the max profit would be the current price minus the minimum price that there's ever been. So yeah, that makes sense. Somebody says you could improve on that. If the price is greater than the last price, only then calculate the max profit. Because if it is less than the last price, then this would not this would not be increasing, this would be decreasing. Unless the min price changes, doesn't it mean? Hmm. Okay. Which it won't, because prices, like this says the price is increasing, so the min price would not change since this is going to be greater than the min price if it's greater than this. Or at least this would be the min price. Cool. Okay, makes sense. Hmm. Nice, neat solution. Makes a lot of sense. What I did here was uh, also actually A0 would be the min price for all times, and I am just calculating the difference between the current price and the min price. I'm actually just doing that. So why not keep the min price array? Okay, that's something to learn. So if you only need the minimum value ever, then keep the like use the either just keep a variable with min price, min value, or maintain a min array depending on if you need min value of any index or of a particular or just one value. Okay, cool. All right. Hmm. I hope there's no lags. Okay. So you have an array for which the ith element is the price of the given stock, designed to find the maximum profit. You may complete as many transactions as you like. You may not engage in multiple transactions. So that was just one transaction. This is multiple transactions. And it says you will have then buy on day 4. Okay, so the thing to remember is that you have to sell before you buy again. So you can't buy stocks on different days together and just hold them. Hmm. So you can take reference of the last question question's answer, which was that you just calculate the difference of the current price from the minimum price. Um, to understand the solution that I'm about to tell you, is that as soon as you see a profit, you sell. Because if you, so you can buy and sell on the same day, right? So let's say there's a situation 157. So you would say buy at 1 and sell at 7. Like in the example 2, they say buy at 1 and sell at 5. So you would have a profit of 4. But if you look at it this way, if you buy at 1 and you see it's 5 the next day and you sell immediately, you get a profit of 4. And now you can buy again. So just since on the next day it's going to be 7, buy at 5 and then sell at 7. So since we have the whole array, we don't have to uh, wonder if the next day the price will increase or not. We already know that, so that can help us decide whether we should have bought on 5 or not. And this might look like it's not a complete picture, but it actually is. It's simpler than it looks. Because if the price is dropping, you don't buy the previous day because you'll be in a loss, of course, till who knows what time. But if you buy on a day where the price is higher the next day, just buy on that day and sell the other day. So we will keep the sum, which is our profit, and just iterate through our list. And if now if you look at this formula, you'll see that whenever you're making a profit, you should be selling because that will add to sum. And whenever you're not making a profit, you don't. It's something similar to the maximum sum subarray, but instead we never go for a loss. Okay, let's test that out. Yep, this says it's right. Hmm. Obviously. I mean, you should write this line in every um sorry, what? Prices. Hmm. Hmm. Okay. You could save some time by calculating this earlier. And then writing this maybe. So it was 863. It's going to be variable based on the CPU availability also on whatever machine it's running. But yeah, simply said, that was an easy question. We're doing easy questions only right now. We saw yesterday that there are about 400 of these. Given that um, I do want to start giving interviews soon, and they're probably not going to ask these questions, I should be switching to medium questions soon. So let me know if you guys feel these questions are too easy and I should be jumping to harder problems. Okay. Valid palindrome. Given a string, determine if it is a palindrome, considering only alphanumeric characters and ignoring cases. Hmm. So we're not gonna solve this. I am just gonna tell you the solution. Um, it's just a tedious one in a way. So basically, what you're gonna do is, let's say we convert the whole string to lower. Then we start from both sides. If you find a space, we skip it. If we find anything except a character or a number, we skip it. Um, in say a while loop, while and change the index accordingly of the right one to one place left, the left one to one place right if it's not a number or a character, and then just compare the current two indices and keep on going till either they cross over, basically till left is less than right. So you just see the answers. It's going to be this. Oh, they say clean C++ solution, and I'm like, might be a clean code. Yeah. Okay. So they've done if. It's better if you do while because that will eliminate all of those inside that while loop itself. All this is going to be the same number of iterations. It's just logically, I think, better to just get rid of all the encounters that are not good. Okay, so while let's say it's not an the left side is not a character, start plus plus, while it's not while the left side is not a character, start plus plus, while the right side is not a character, end minus minus. And when they're both characters, you convert them to lower and just compare and return false in case. Could use two whiles, but I think that the solution is better. Okay. Oh, he's mentioned that OP is failed. Let's check what the expected output is. Maybe he did not write less than equal to. Yeah, he did not write less than equal to. I think it should be less than equal to. Yeah. Let me show you. Let's indent this a little better. Okay, my bad. Yeah, this is fine. Console test case is 0p run, and it's gonna show true, but you got false. Oh, it's accepted. Did I write 0p? Or did I write OP? 0p. Um, hmm, okay. Maybe he edited the solution. Uh, there's no replies to this either, I think. Okay, anyway, uh, like I said, simple question. Don't really need to discuss more than that. How many am I doing a day? There are 1335 easy questions. I don't think there are 1335 easy questions. I think there are 1335 total number of questions. Let me just confirm that. Yeah, that's the total number of questions. If you see there's, if I see 100 per page, there are 5, 7, 10, 9, yeah, about 13 and a half, whatever, 1335 is the total number of questions. So I've not targeted anything as of now, as to how many questions or so I'll be doing in a day. Yesterday we did about, so I'd already done 9 questions before I started streaming. We started streaming yesterday, wherein I think I did about 20 questions, all before trees. So yeah, something over 20. So since they're easy questions, they're not going to take too much time anyway. And okay, let's do some quick maths about how many questions. Say if I do 20 easy a day, then to do, how many was it? 400. It's gonna take about 20 days. So I would not be aiming for that probably. Um, since we're not doing all questions and weekends, I will probably be doing more. Uh, I guess I'll probably give it this week, and then I'm gonna start with medium to answer your question. Mostly looking for advice on how many someone in your position should aim to do to have a good shot at interviews. Oh, okay. So, um, although my title does say that I'm doing this sort of so that somebody hires me, but it's not really about that. It's just practice. This is sort of how I have to motivate myself to do this because I wanted to stream for a really long time now. So I thought I'd stream games that I play generally. I'm a hardcore gamer, which I actually just stopped being one this year as part of my resolution. I uninstalled my favorite game, which I'd been playing for over 6, 7 years or so. Yeah, 6 years. So yeah, that the purpose of that was two things. One, I was getting really toxic, so I wanted to stop that, and the second being I had to focus on studying the for a new job, which is what I'm looking for. So that's where the title comes from, but it's not mainly for that. It's also for just learning purposes as well. Um, Somebody in my position. So it's not really about the number of questions you do only, it's about the type of questions you do as well. So um, there are some questions that are easier than others, which would take say around half an hour or so in general if you're doing it for the first time, 10, 20 minutes even. Um, Tough questions generally take longer, say an hour or so. Uh, Trees was generally mostly easy questions. Some traversal ones I've not done. These are the traversal ones, and I guess this is one other question that's left. Um, I actually some focused on doing it sort of company wise. After a point, after where I felt I've done quite a few questions, so I started doing questions company wise. So I covered array, strings, linked list, trees. mostly. Um, I'm not great at DP, which you can see over here. Um, so yeah, it's not really about how many questions you've done. In general, I guess if you do ask for a number, depends on how long you have to prepare. Um, so interview bit does give you a sort of number that is if you get 500 points a day, you'll probably be completing uh, uh, enough questions in a month to be ready. So, which given that interview bit, I think also has somewhere around over 1,000 questions. Um, yeah, so your question was how many questions you should be doing. Let's say roughly about, if you say around 500 questions is something that you complete, which is almost like half of this, only on, uh, not on concurrency or database or shell, just DS algo. So I think that should be a good start. I think that's when you would be really capable of going for getting out of an interview and not feeling bad that you sucked. Okay. I think I've done a similar amount. I'll count these out and let you guys know how many I've done actually. But let's get back to solving problems for now. If you have any such questions, just drop them in. If it's some research that I have to do on my own, I'll do that off stream and let you guys know. Given a non-empty array, finally non-empty, I don't have to return. Let me check for nulls. Every element appears twice except one. Find that single element. This is an obvious one. For I equal to 0, I is less than. Let's change the name for faster typing. I plus plus. Sure. Uh, hmm. Okay. So I think everybody would be knowing this question. Basically, if you so question is every number appears twice except one. Find that single number. If you do a XOR of a number with itself, it ends up being cancelled out uh, to 0. And if you do XOR of a number with 0, it gives the number itself. So how this works is how many ever numbers you XOR, in the end you reduce all the numbers that appeared twice to 0, and the only number that's left that does not convert to 0 is the number that only appeared once. Hence the simple straightforward solution. Um, List operations. Ugh. Hash table. Again, yeah, hash table would be on. Math would be, huh? Huh? Bit manipulation, yeah. So this, I guess, is the. It becomes obvious after time. Won't lie, I've already done this question, so it's pretty easy. I did this literally like 2 days back, trying to help somebody out. Again, I won't be coding this, but I'll definitely go through the logic. Uh, oh, did I? Yeah. Okay. So, um, actually, on the logic, I don't think I can explain it without pen and paper. Uh, maybe if I use just write it down. I will try to put it into words. Although there's a great video that if you watch, I think 3 or 4 times, you will definitely get a hang of it. So basically, how you detect a cycle, determine if it has a cycle or not. Okay. This one is actually fairly simple. Um, all you have to do is start a pointer from the first node. So I'm sure you know about slow and fast pointers. So a slow pointer is one that moves one node at a time, and a fast pointer is one that moves more than one node at a time. So here we'll take a pointer that moves twice as fast. So we keep 2 pointers, one at the start, both of them at the start. One moves one node at a time, and the other one moves 2 nodes at a time till we reach um, till both of them are pointing to the same node. So that would never happen. The fast node would probably reach close to the end of the list in case there is not a there isn't a cycle. And if there is a cycle, then they would be looping inside the cycle multiple times before uh, clashing. So yeah, and if they do clash, basically there is a cycle. If they don't, there isn't one. So I'm just gonna copy the solution from here, since this is a very simple one. I think there might be a okay, yeah, this is the solution. It's a do while because at the start slow and fast is same, so I have to move it once before that happens. Do a control reaches end of non-void function. Okay, return true, I guess, and return false here. Hmm. Yeah, so slow pointer moves one node at a time, fast moves twice. Yep, pretty straightforward. Or just let's look at the solution if you want, the one given by leetcode. If there's something different. Hash table. Why would you even do that? That's extra memory for no reason. 2 pointers, yeah, that's what it says. You can go through the explanation if you like. Um, as to why they meet is, so say there is, so the length of the loop is x, um, and um, they both enter the loop at different times, right? So consider a normal situation where two runners are running on a field, uh, and they can either keep 1 steps or 2 steps. So there will definitely be a situation um, where the runners would cross each other, because the yeah. Yeah, so the video that I was recommending for cycle in linked list is this one. I really like this guy's videos. You can search for him as GKCS. Um, the explanation, like the maths, is in the end of the video, uh, as to where and why you find a loop. Not really why, but where you find a loop and how you find that loop, the starting of the loop. Although I also did have to see that video a few times to understand the solution. Okay, design a stack that, one sec, wholesome chat. Design a stack that supports push pop top, retrieving the min element in constant time. Hmm. Okay. Hmm. Hmm. So if we okay, let's see. So getting the top element is just picking the top element that if we have a pointer available to the top node, we can access it in O1. Pop to remove the element if we have a pointer to the topmost element, and maybe we might need to the second top element. Then we can also remove the top of the element. Let's say we store the size as well whenever we push a pop. Push can be done in O1 in a linked list, definitely. But get min, retrieve the minimum element of the stack, cannot be done in O1 in a linked list. So if we keep uh, an ordered set inside our stack, where the um not an like an ordered map, like basically a hash map, we can store the value as key, and like the object that we're pushing as key, and Well, what do we need to store as the value? Nothing really, I think. Um, so a stack, we have the if we have a pointer to the head in a linked list. Okay, so okay, let's say this is a stack. We will have local variables. We'll have a map of integer to, I don't know, maybe integer, let's say, m. Let's open map C++ reference parallelly. We will also keep a pointer to the do we have something like a list? Yeah. Keep a list pointer. No, not an entire list. We just need a pointer to a node. Hmm. Where we have a um um it's basically m dot. How do you insert an element in a map? Modifier insert m dot insert pair of integer, which would be x comma x. Um, so m this is what I'm getting is so with at oh no. So maybe something like m dot begin first, maybe. Hmm. hmm. So the iterator, yeah. The top. Okay, so how do I keep a linked list in here, dude? Okay, we'll not look at the solution. It should be an easy question. Show hint. Consider each node in stack having a minimum value. Hmm. But if you pop and remove the minimum element, you have to update it. That you can't do it in constant time. You have to update the list. Okay, I think we look at the solution. Using two stacks, quite short and easy to understand. Okay. It's another solution using one stack. Okay. Okay. So you keep a stack. Top is stack.p. You keep saving min, of course. Pushing. If x is less than the minimum value, you push the minimum value. Oh, because that will not get removed. That will get removed first than the last minimum value. That's smart. And then you push to your. Oh, okay, that's quite a cheat. So basically, what they did was, uh, you keep the minimum value twice. Takes the same amount of space, I guess. You keep the minimum value twice. So whenever you're popping, you check if whatever you've popped is also the minimum value, then you pop again. And sorry, are you keeping twice? Yeah, you are, right? Oh, you're keeping the last minimum value twice. So if the current value is uh, so keeping the last minimum value twice. So if the current value, the one that you're popping, is the minimum, then you pop the duplicate of the last minimum that you had so that your latest minimum has only one copy and all the other minimums have two copies. Cool, man. That makes a lot of sense. So I think if we write it with our own hands, which is absolutely unnecessary, uh, we will not forget it. So step one, maintain a stack. Step two, top is st dot top, return min, keep an integer min. If so while pushing, if stack dot top is not equal to null, then if stack dot top is equal to the minimum value, you push the minimum value again, and then you set, oh no, sorry, if x is less than equal to min, then you push the minimum value again, reset min to stack, and then you push x. And while popping, if and uh, so if the top element is equal to the minimum value, then you pop the duplicate copy of that minimum value as well. Reference belong to, huh? Oh, probably over here. If stack dot if not st dot empty. Yeah. Pointer points here. Memory cannot be printed. Pointing to misaligned address requires 4 bytes. Huh? Do I have to initialize the stack or something? Hmm? Oh, if why do we care about this? Over here, it's actually part of this. Hmm. Oh, sorry. I've not been talking for a while now because, yeah, I'm stupid. Okay, so we keeping duplicate copies of everything except the last one. So when we pop, take the topmost element, we remove it. If it was the minimum element, then we remove the duplicate copy uh, of the ah, we can't really remove it just yet. So now if sorry, we're keeping two copies of what? If sorry, yeah. So it was minimum. Uh, if it was minimum, okay, I'm gonna check it one more time. So if whatever's at the top is the minimum, how's it gonna be the last minimum value? It's just gonna be the last value, isn't it? If x is less than min, then we push the minimum value just before we push x. Hmm. Okay. So this is a useless channel, guys. You can just check out the discuss forum and yeah, you never have to come back to this channel again for just sit watching me sit and do nothing. Oh, it's logged. That's nice. That's some question we get to skip at least. Okay, intersection of two linked lists. This also I have done before. I was actually asked this question recently in an interview. Uh, so this is very straightforward. Um, Basically, what you do is you iterate both the linked lists together till one of the iterator reaches the end, and then you iterate the remaining one and count how many steps you have to move, which basically is the difference in the length of the two linked lists. Next, you iterate the longer list, which you will know from your previous, uh, which you can just store that information from your previous iteration. You move that list the number of times it's longer than the smaller list which you just calculated, and then you move both the lists together, and when the reference of both the pointers that you're uh, the iterators that you're using is the same, means you have found the merging point, and then you return that. Oh, this is actually an example. So I hope I did it. I did. Some case. Oh, no case failed. Amazing. Okay. I hope you didn't need more time on that. Okay. To sum, given an array of integers that is already sorted, find two numbers such that they add up to a specific target. The should return indexes if they such that they add up to the target where index 1 must be less than index 2. You should return are non-zero base. You may assume that each input would have exactly one solution. You may not use the same input twice. So I'm not sure how it's different from two sum since it's already sorted. Why don't we So this was not sorted, and when we sorted it, we iterated left right. Uh, okay, I'm not sure if this will work now. I'm not sure why they've asked for a for this. That does make sense that they've asked the same question again. So probably there's some trick to it, which we will know after we submit our answer. I'm just copying the to some answer to see. Um, okay. So the only difference that I see is the only difference that I see is it's already it's already sorted. So the answer to two sum is actually hash maps where you store the value and then if you find the uh, target minus if target minus your current value of while iterating to the array is present in the hash map, then uh, basically that's the pair. And it's an unordered map so that the uh, order of these remain the same. Okay, I don't think we even have to discuss this. Two pointers, everybody says two pointers. Left, right, plus, plus. Yeah, fair enough. Um, Excel sheet column time. I have a touch comment. When not using the terminal built into LeetCode, what IDE do you use? People have been telling me to use Vim, but I do not know if I should use Vim plugins with some IDE or if I should use plugins to make generic Vim better. What are your thoughts? Um, so I don't really write C++ code at work. I write C sharp, and since it's an application that we have to develop, we use Visual Studio. So I'm using the normal Visual Studio editor in dark theme with no extensions or anything. Uh, Dark theme seems most comfortable with that. Apart from that, yeah, even on interview bit where have practiced, I use Monokai theme, which I think is the same as what I'm using here. Yeah. Apart from that, even yesterday I mentioned an IDE that is available for, like, if you don't have one, um, if you don't have, say, something like Visual Studio Code to debug, you can debug in Visual Studio Code if you have the extension to. Um, yeah, if you don't have something like Visual Studio Code for debugging, um, or what was that with the compiler that we used in school? I have no idea. It's very basic Turbo C, I think the name was. Yeah, there's this online debugger. Of course, it's going to be slower, but it's a decent one. You have a ton of languages, and it allows you to put in breakpoints and see the entire, uh, all your variables and any you can watch variables as well. So yeah, I think this could be useful if you, I mean, just for debugging. For coding normally, I think Visual Studio Code might be pretty light with IntelliSense. If you want to try, I haven't personally tried a lot of IDEs since for work, I usually use Visual Studio only. Yeah. Okay, let's get back to the question. Given a positive integer, return its corresponding column title as a pair in an Excel sheet. Oh, okay. Hmm. So is it an integer? Yeah, okay, then that should be fairly simple. Um, hmm. So while n is greater than 0, I'm not sure if this is going to be the solution. Okay, so what I can see is Z was 701. So it's not just like so and AB is 28. So what happened was uh, you took N and then you divided it by 26, let's say. Um, so 701 by 26 is 26.9 some, and 26 times 26 is 676. So 701 minus 626, sorry, that minus 26 times 26 is 25. So your first value is going to be based on, so you're going to divide by 26. That's going to be your first character. If it's 0, you're done pretty much. And your second character is going to be the remainder when you divide by 26. So you have to keep these two characters all times and then reduce n. I've, yeah, I think that's how this question would work. So int c1 is n by 10, sorry, n by 26, and int c2 is n percent 26. Okay, I'm not very sure of this because this might actually give me the last character instead of the second character. Hmm. No. Yes, that's right. It's gonna give me the last character instead. So if C1 is less than 26, which means the next character I would still need to divide by 26. So do while n by 26 is greater than 0. Actually, I don't need to do that. While n is greater than 0. So yeah, I think what I was writing was fine. If C1 is less than 26, C1 is less than 0, else if C1 is less than say 26, then we have to quit essentially in these two cases. Um, oh sorry, is equal to 0, or if it is less than 26. Int C2 is equal to n percent 26. So convert number to character C++. I think you should brush up on this 48. Mm, I think you just add 48 to that. Maybe what? ASCII code of characters. So A is this 65. So let's start with the return char of 64 plus C2. If it's less than 26, then you return the okay, let's make another string, string ret, which will be blank, um, ret plus this, ret plus push back. Yeah, similar thing here, except that C1 also has a value, so you need to add that as well. Otherwise, what you would be doing is this, while okay, let's see if this even works. Okay, better test case. 701. Let's try like a huge number afterwards. If this passes, that is. Yeah, okay, so that gave us Z, Y, A at for some reason. So, okay, so let's just debug that and see what happened. So I think we're on the right track, probably. Um, that's what we expected. Oh, actually, we don't have to do this, I guess, because that will be handled over here. Hmm. What? C1 is less than 26, which means um, which means what? If C1 is less than 26, so we had 28, uh, divided by 28, it was 1. So it was 1, which meant there's only two characters that we need to add, which is the C1 and this one. C2. But if it's greater than 1, then how did n become 26 from 701? Oh, it is 26. Huh. So dividing it by 26, what is, sorry, 701 by 26, what was that? 26 point something. ZY, so 701 minus 26 times 26. What is that? That's 25. Hmm, I'm I'm pretty confused. Um, okay, instead, let's just write what we wrote. Minus equal to 26 times 26. What? That's weird. Oh, hmm. So C1's not really. Hmm. It's RFU. Okay, so I think I failed. Does he reverse it? Yeah, so he takes, so you divide by, so you take the remainder and you get the last value that you're gonna get, and then you add it to the front, then you divide by 26. Hmm. Hmm. Okay, I guess it's fair to say that I might not understand every answer straight away. Uh, so if somebody could help me explain this, I think that'd be great. Like just the math behind it. Um, oh, there is some math behind it. So this is 26, 2 times 26. Okay. Hmm. So what he's saying is that the last number uh, would the last number would actually be not related to 26 uh, in a way. So if we use n minus 1 times 20% 26, we'll actually get the last character, how far ahead it is from A. And I think this all would get truncated. Um, hmm. And then if we divide it by 26, this will be this plus 1, and then this will all be removed, and then we remove this 26 as well, or whatever was here if there was anything. Otherwise, subtract 1 from here. Hmm. That's that's clever. Oh, it's going to be removed anyway. So because you converted to 25 first, then you divide by 6. So this is gone, and then you subtract 1 again before calculating the second last character. Hmm. Nice. So this was sort of this wasn't strings. This was, I would say, just maths. If you have to categorize. Hmm. Okay. Cool. Majority element. Almost been 2 hours in the stream. Given an array of size n, I'm gonna open a packet chips. Let me know if it makes too much noise. Given an array of size n, and the majority element is the element that appears more than n by 2 times. Hmm. Okay. 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 So, sorry. Unordered map of integer to integer. M. Um, let's iterate over the array. Okay, so a simple solution looks like you push an element the first time you find it into a map, and every time you find the element already existing in the map, you increase the count that's against it, and if the count increase the size of the array, that is your answer. So let's just keep the size separately. I wish they had the option to prettify the code. Never mind. Okay. Um, unordered map C++. Find okay. Auto ID equal to m dot find nums I if it equals m dot end, m dot insert, m dot insert pair int nums I 1 else it second plus plus if it second is greater than size by 2, return it first. It's never gonna reach here, so let's just verify the dot. Okay, looks good. Okay, let's look at the actual solution. Brute force, let's just skip that already. Hash map, it takes O in time and O in space. Sorting, um, what? What? Holy shit, that's like crazy logic, man. So basically, um, so let's say you there's an answer somewhere, okay. So let's consider the first element is your array as your answer. So now if this next element is the same as that, so it's providing proof towards the fact that this is going to be your answer. So you add 1 to count. And when you encounter an element that does not provide proof towards your answer, then you add -1 to that. And you keep doing that till, so basically when you have proof that your selected element is the answer, you add 1. And when you have proof against it, then you subtract 1. So what will happen is, since in the end, your answer is going to be positive, obviously, and somewhere in the middle or in the end or wherever, it will definitely hit 0 when you've encountered as many proofs towards the selected number being your answer as you've encountered against it. Because the number of elements, number of time that the answer occurs is more than half of the size of the array. So let's say you had 10 was the size of the array and it occurred 6 times. Let's forget about where it came. So let's say randomly after the first 8 iterations, 4 were in favor and 4 were against in any order. So your count has become 0. Um, and then if count is 0, then the next number you encounter will be your answer, which are in this case of the 10 sized array is your answer. Let's take another case where all the 6 answers are on your left. So say it was the first element and second, third were something else, and then fourth and fifth were your answer. So first case, count is 0, your answer is what it's expected to be. Second case, count becomes 1 after the first loop, then becomes second after the second loop. Sorry, it becomes 0 after the second loop because second number is something else. Third loop, since count is 0, your the number at the third index, which is not your answer, becomes the possible answer. Count becomes 1. Since the next number is not, since the next number is the actual answer and not same as your current expected answer, count becomes 0 again. And then when you encounter your actual expected answer again, count becomes 1. But since count was 0, that becomes the candidate for being the answer. Holy shit, man. This was crazy good logic for ON space O1 space ON time. Hats off to these guys, man. It's pretty good. So I'm guessing in an interview maybe you should try this, and if he says in no space, then do this. Or like if you can remember this, it's not really hard to remember or anything. It's just the easiest way of remembering is that each number is a proof towards or against that number itself being an answer, and you just have to count the number of proofs, and whenever your proofs cancel out each other, the next number is your candidate. I I don't know if that's actually better than remembering the algorithm itself, but yeah, nice question, man. Nice question. All right, we are over here. I think. Excel sheet, column, number. Okay, this is sort of going to be similar to this, this one, which we didn't solve. So essentially, this is much easier. So you take the first character, convert it into digit, convert it into a number, and you keep iterating and multiplying your previous result by 26 and then adding your current number. For int I equal to 0, I is less than s dot size, I plus plus, int answer equal to 0, int temp equal to s I minus a plus 1. Answer equal to answer times 26 plus temp, return answer. Hmm. Oh. Coming from this to this, I don't think that would help. I mean, knowing the answer to this and then coming to this is fairly simple and obvious if you read the solution that I was going through. Uh, but I think this one is still a little tricky. That's why it has a relatively lower submission rate despite being an open question. Factorial trailing zeros. Given an integer n, return the number of trailing zeros in n factorial. This one is again is fairly simple. So the logic being that every 5 factor of 5 that you encounter is going to give you 1 0 at least. But that's not all. Like say 10 fact 25 factorial would actually give you two fives and sorry, not two fives. Just forget what I just said. Um, yeah, so basically you just have to check the number of factors of 5 that you're getting. Um, so 5 factorial would have 1 5, 10 factorial would have two fives, 10 and 5, 15 factorial would have three fives, 20 factorial would have 20, 15, 10 and 5, so four fives, so on and so forth. So what it looks like is int answer is say 0 and while n is greater than 0, n is equal to n by 25, sorry, n by 5, ans plus plus, then gives you two fives, right? So doing this would actually just stop your is this really the answer? 1, expected was 0. So while n is greater than equal to 5, okay, let's test a bigger test case, say 100. Hmm. I'm sure this is not the solution, but this just looks like the pattern. Oh, 25 would not actually have one 5, but it would actually have two 5s. Hmm. So the answer is actually um, n% 5, sorry, n divided by 5, then n equal to n by 5. Hmm. Hmm. Yeah. Basically, the number of times 5 comes for your current number, the biggest factor of 5 between the multiples of 5. Uh, that's the number of 5s you're gonna have initially, and then you don't have to check for 5s between n by 5 and n. So like let's take 25 for example. So 25 by 5 is 5, which is the number of 5s that are between 5 and 25. Similarly, 50 by 5 is 10, which is the number of 5s that are between 25 and 50. So it's going to be like 49. So 49 by 5 would be 9. So that's the number of times 5 comes as a multiple of numbers between 25 and 50. I'm not sure if you're able to understand. Let's look at one solution. 0 comes from 10, 10 comes from 5. If there's a 5, there will be a 2. Because 500 divided by 5 is 20, so there are 20 multiples of 5 between 1 and 100. Yeah, exactly. But wait, actually 25 is 5 times 5. So 25 has an extra factor of 5, which will produce an extra 0. So we need to know how many multiples of 25 there are. 4. So our answer is this. Yeah, I think that's another way of looking at it. So you have to check how many times all the multiples of 5 occur. Um, since 5 itself will be contributing one time, and then there and its multiples would be contributing some other, like one time for as many times, as many factors as it has till the input. Okay, cool. Combine two tables. SQL? We're not doing SQL. Oh, so this is 400 questions of all topics. Let's just sort for algo only. So that's about 10, 20, 30, saved about 60, 70 questions. Cool. Okay, rotate an array. This is easy. Okay, I have a friend who this question was asked in. Okay, maybe not the same question. Oh, rotate an array. Rotate the array to the right by k steps where k is non-negative. So okay. Hmm. So either you take O1 extra space does look like an ONK solution where you iterate through the entire array, just moving it one step at a time, saving the next integer, and when you reach the end, you set the first character as the last one. Otherwise, it's a vector. So you can push the first k minus size minus k elements to another list, and then take the remaining array and put it to the start of that list. Just combine those two vectors basically. So it looks like fairly obvious. Might as well look at the solutions. Oops, sorry, stop. Hmm. Brute force TLE, which was ONK using extra space. This is also the same thing basically. Moving it to that index, percent the length, so it resets to starting. Using cyclic replacements, ON. Huh? How's that? Um, so are the numbers getting swapped? So let's say this gets swapped. But then you have to swap this also. whatever the remaining array was. Let's see. To next equal to current plus current is start, previous is nums start, next is current plus k. So this is where you have to move the uh, current element. Nums next is previous. Cool. You save the number, and then previous is temp. Okay, and then the current is next count plus plus. Hmm? Uh, while start is not equal to current. Okay, so let's look at the example with that. It was 1, 2, 3, 4, 5, 6, 7. Make it move it 3 places. So current is 0. Previous is num 0. To next is current plus k, which is 2, 3, 4. Temp is 4. So you switch 1 and 4. And now you're pointing to what's current right now? Previous is temp, which was nums next, which was 4. Now previous is 4, which is at the first position. Current is next, which was the fourth position. Current is 4. Start is not equal to current. Okay. That's again count plus plus. Okay, this is going over my head. Maybe I've been at it a bit too long. So next is current. Say, what is current? Current is next. What was next? Next is 4. So current is now 1. So next is 1. I mean the 0th index. Next is it 1? So it was 0, 1, 2. Sorry, 1, 2, 3. So 3 plus, it's 0, 3 plus 4, 1, 2, 3, 4. Yeah, it's 0. So next now 0. And I'm so confused, man. Really confused. Okay. I think let's go over it later. I'm honestly really not getting it right now. Is there any other solution? Oh, okay. Yeah, okay, so just reverse the entire thing, then reverse the first k, then reverse the n minus k. Fairly simple. Just flip, flip, flip. Yeah, I would do this rather. Please, in the interview, do this, don't do this. This is like this, you'll confuse yourself. Okay, reverse bits. Hmm, familiar name. Reverse bits of a given 32-bit unsigned integer. What? Okay, I have no idea. What they're expecting. I just return n and see the expected output. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, close enough. Your input this, output this, expected is 1. I think what they want us to do what? I mean, is there any logic anywhere here? Okay, let's just see what they're doing. So the top of the number is 0 and they left shift it by 1 and OR it with the last bit of n. What does that even mean? Oh, but in the examples it's something completely different, isn't it? Oh, it ain't. Oh, it ain't. Oh, I'm sorry. Oh, okay. So basically you have to reverse the bits only. Hmm. Sorry, my bad. I would like to know the condition. I'm not sure about that. Um, M, we left shift M by 1 and oh yeah, 32 times. We left shift M by 1 and we hmm, I think this and 1 is oh yeah, so basically take the most significant bit and then I guess you hmm hmm yeah, so that was fairly simple. I didn't read the question properly, I think, or I didn't see the examples properly. I don't know what I was looking at. Yeah, so it's reversing the bits only. Number of 1 bits. Um, had a function that takes an unsigned integer and returns the number of 1 bits it has. Again, same thing for int I equal to 0, I is less than 32, I plus plus, uh, int sum equal to 0, sum plus equal to n and 1 and redshift 1 while n not equal to 0 return sum. So when you completely right shift it, like when it becomes 0, uh, when it becomes like you keep right shifting it, it becomes 0 in the end. When you've shifted all ones, because in the left side keeps getting set to 1. Ah, fastest solution. Nice. I've done this before, so yeah. Okay. Let's see if anybody's still on the stream. Any questions? Okay. So it's been about 2.5 hour, guy. 2.5 hours, guys. I think I'm gonna stop the stream for a while. I'm just gonna go ahead and have dinner. So if you have any closing questions, go ahead. Oh, I've not been. Hmm. I'll be back in a minute or two. If you have any questions, go right ahead, or else we'll close the stream for now, and I will be back in an hour or so. So, see you guys then. Testing, testing, testing. It is. Okay, I'll just restart the stream, I guess. Hmm. Hmm. Okay, new session is up. Let's do it. Mhm, 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 mhm. Okay. Hmm. Oh, I should stop fooling around. And let's get started. House of a Robber. Sorry, House Robber. Uh, it's a little cold. Okay, you are a professional robber. Each house has a certain amount of money. The only constraint stopping you from robbing each of them is that the adjacent houses have security systems connected and it will automatically contact the police if two adjacent houses were broken into on the same night. Given a list of non-negative integers representing the amount of money each house has, determined the maximum amount of money you can rob tonight without alerting the police. Hmm. So you can either loot all the houses, taking two elements at a time. You can either loot all the houses on the left. Ah, actually no. Since if you skip two lefts and skip one and take the right one instead. Hmm. So what I was thinking take that would have been stupid. So take like these are the houses. So you pick 1, 2, 3, 4, 5, 6, 7, 8, and either pick all lefts, that is 1, 3, 5, 7. And for the last case, you can also pick the right one. And otherwise, you pick 2, 4, 6, 8. And instead of 2, you can also pick 1. So whatever the maximum sum is, that would be the only possible answer. But what I was missing was that let's say it is 1, 2, 3, 100, 4, 5, 6. So if you're going 1, 2, 3, 4, 5, 6. Sorry, 1, 2, 300, 4, 5, 6, 7. So if you pick 1, 3, 4, 6, 1, 3, 4, 6. Yeah. Uh, Instead, if you picked 1, 100, 5, 7, that would be much better. Or say if this was 200. Coming from the other side, if you picked 7, 5, or 6, 4, 200, 1, or 7, 5, 7, 5, 200, 1. That would be better. So you can't just pick alternate numbers. Hmm. Okay, so let's. I guess sometimes when you're not able to think of any solution, any good solution, you should always mention the brute force solution to the interviewer because he will come back to you asking for a better solution in case you can think of one. So if you're not able to think of something better, do mention brute force without taking a long pause because then he'll be like, he's not even able to think about the brute force solution. He's so stupid. Yeah, don't do that. But there's 379 questions. Exactly, I think. 57 seems about right. 50 out of so skipped 1, 2, 3, 4, 5, 6, 7. Yeah. So we can just do next over here. Hmm. So brute force is you pick one house or you don't, and if you do pick it, then you can't pick the next one. And recursively keep doing that for all. the items. But that would probably give DLA. That's probably n to the power n. 2 to the power n, sorry. It's probably it's maths. Maybe something simple. Hmm. I think I'm gonna look at the. Hmm. Hmm. Uh, temp is max of previous plus nums I and current. Previous is current. Current is temp. So max is previous plus. Hmm. So current is temp. Uh, if current, so say first item, you can pick up the first item, and the previous item was picking up nothing. Then current is what you current is the first item that you picked. Then temp is max of picking nothing and then picking the first item or picking sorry and the second item or picking the first item. So basically first and second item. Previous becomes current, which is the first item, and current becomes the second item if it's bigger than the first item. So this is first and this is second. Previous becomes first and third. Previous becomes second. Current becomes first plus third. What if temp is current? Then pre is current and current is also current. And what you're doing then? Hmm. So they're doing what I thought. Hmm. They are. It's just picking alternate uh, values and checking if the even alternate is better or if the odd alternate is better. But like that guy suggested, this test case should fail because hmm. But according to that solution, that test case would fail. Quite a debate. Why so? Why so, man? Why so? Why does this work? Hmm. Happy number. If number is happy, starting with any positive digit, replace the number by the sum of the squares of its digits and repeat the process until the number equals 1. Or it loops endlessly in a cycle which does not include 1. Okay. One observation is the if the number of digits, if the number of odd digits is odd, then I don't think we'll ever have a solution. Or will we? We will. We might. I mean, I don't know. Because the final number will always be odd. 101, but then 101 plus 101 is 2, it's 4, then it becomes even. So no, not really. Hmm. Hmm. I think I might know how to do it with some memory, some extra memory. So let's just say we create a map and if so basically return true here, and if m dot find n not equal to m dot end. So basically if it exists in the map, which means it's already come, this number has occurred before, which means we're looping now, then a return false. Um, and let's just m dot insert pair of integer n comma n, run code, did give true. What about some other number, let's say false. Okay, so it gave true for true, false for false. That's all I can hope from a question, from a code, man. Works how it's expected. So this is correct. Now they don't have a solution here. Oh, one space, no magic math property involved. Hmm. Let's see what they did. Hmm. Oh, wow. Okay, I did not see that coming. Hmm. Hmm. Nice. So, basically, what they're saying, if there's a loop, then if you remember linked lists, then if we take two steps forward and one step forward, those steps meet at some time. So in here, instead of calculating the square, you also calculate the square of the square, and so on and so forth. And if there's a loop, they'll actually coincide. Nice. I did not think that. Nice. Hmm. Remove linked list elements. Remove all the elements on linked list that have the value val. Very unnecessary. If head next. Oh, did I not say anything? Okay, so basically, if head's null, return null. If we have the value at the start, then we remove all those elements till we find an element that is not that value. So we can start removing the elements next to our current pointer. So if the value of the next element is the target that we're looking for, then we will make head next head point to the next element. We could do this in a while also, um, so that the contiguous elements are removed without going out of the loop. Okay, think I've checked all nulls. Output is blank. Oh, sorry. It's because we had to run not head. Awesome. Hmm, I didn't expect that. So you're here. If head's not null, if head next not null, and it is 2, then head dot next is head dot next dot next. Point here. Well, now and head is now. Oh, actually, that's why I wanted to do the while. Yeah, it's a little slower than most solutions, so let's just check if anybody's done something better. No, it's just using pointers. Yep, that's fine. Same thing. Oh, is it because you looked at too many solutions? Okay, maybe. Yeah. Count primes. I think this is mathematical. There are four prime numbers less than 10. Okay, count the number of prime numbers between 1 and n. I think that's mathematical actually. I think there's a formula for that. So the obvious answer is to go from 2 to 2 to square root of n, I think. Nope. From 2 to n only, and check if each number is prime or not. That's one option. But I think there is a formula for calculating the number of primes. So I'm just testing to see if I can find a pattern. So before 20 there are 8. So there's not 10 in every row, of course. I think it's maths. I don't remember the formula. Or basically mark all the factors of all the numbers up till that number. Hmm. Ah. Hmm. Hmm. Okay, I haven't said anything in a while. To my zero viewers. So actually, yeah, this is the CEO of Erathes. Nope, Eratosthenes. Shh, don't tell anyone. Yeah. Yes, this is something that you have to remember. People not coding it because it's sort of tedious in the naive way, and they just see the solution, they just move on. I lost electricity, so I'm on stream for over an hour now. For more than an hour now. Given two strings, determine if they are isomorphic. They are isomorphic. If the characters in S can be replaced to get T, all occurrence of a character must be replaced with another character while preserving the order of the character. No two characters may map to the same character, but a character may map to itself. Oh, okay. So for T, if S dot size is not equal to T dot size, return false. Then let's make a map, and we iterate over the length of the strings and insert uh, in our map one character from one string as the key and the other as the value. So if m dot find si equals m dot end, if you didn't find it, m dot insert pair character pair si ti. Awesome. I'm just gonna turn on feedback. Yes, I do understand JavaScript. Sorry for not responding sooner. Hi. Yes. Um, else, if you did find it, if m I, sorry, if si is equal to ti, sorry, if si is not equal to ti, then return false. And in the end, if everything goes fine, return true. Hmm. Where did it break? If si is, oh, sorry, if m si, oh, sorry. Yeah, so if you do find the map and if the mapping same as the answer that you're looking for, if the mapping is the same as this mapping, then you're good. Uh, Maybe we need to keep two maps. The other one for the reverse mapping. But what we're actually checking is, okay, I think this might work. Let me just check. Hmm. Okay. Output is true, expected is false. Because, so, oh, sorry, 2 dot insert. The second one, it is saying that if B is not found on the map, put it in the map, cool. If A is found, hmm, cool. Now, let's see if there's a better solution with less lines. Okay, 0 ms. So instead of map, he's done it with characters. That's the same thing. Hmm. hmm. If you don't find them, else if you find either them, return false. Hmm. This is what I want to see. This is the same thing as a map. Okay, cool. I guess I'm okay with my answer. Awesome. Somebody said something in chat because of language barrier. Uh, I now thought it would be hard to explain what I need. Maybe you can just put it in Google Translate and see if that helps. Or if the question, if you have the, if a link to the question or something like that, anything that I could help you with. Or if you're just looking for help with your uh, work, then that's different, I guess. Um, okay. Anyway, thanks for the follow, man. First, I made this. Okay. Get element by ID n. ID is n for I is less than n plus plus a equals math dot round minus 100 plus 100 times math dot random document at right abr. Okay, but then I thought how to find any value. Hmm. I'm not sure. Is it a character? Um, I am not sure what exactly you're asking. Is what a character? Hmm. Um, okay, I'm not sure, but I'll try to help. Um, so what I was saying was that when you're doing that document dot write, um, just write a tag, let's say maybe a span, and give it the ID as the I that you have. You'd write it something like this: document dot write span plus your iterator plus closing tag, and then your value, which is a, and then a closing span tag. And a BR after that if you want. So when you do write that, let's say 1 and 2. So you'll get this 2, and if you do document dot get element by ID, you pass 1, you'll get this element. I'm not sure if this was your exact question and if this helps. Just refind the stream if I closed it too quickly. Cool. Awesome. Okay, we were on the reverse linked list. Question. Given a linked list, reverse it iteratively or recursively. Hmm. While true, I don't know how long I'm gonna do this. And I'm definitely gonna need a previous node, I think. Previous. Um, and let's say we take a current node as well. And let's take a next node. Next. Next is equal to current next. Current dot next is equal to previous. Previous equal to current. Current equal to next. So basically, just look at this small example. Previous is null right now. This is the current. This is the next node. Uh, you store the value of next when you start. Then you make the current point to the previous node, which is null. Then you make um, your current node as the previous node and your next node as the current node, so that your next node can do the same with like your next node, which is now your current node, can do the same thing that we did before. So when do we stop? When next null. Um, while current is not equal to null. Okay. And what do we return? We return the previous node, which when the current will be null, this will be the previous node. Yep, it's gonna break for some case where I don't know, something is null, maybe. No? Wow. I do not believe that. That's unbelievable. You know, I used to struggle with this problem when I was in college. Yeah. Yep, exactly this. Okay. Contains duplicate. Hmm. Given an array, find if an array contains any duplicates. Your function should return true if any duplicate values appear in at least if any value appears at least twice in the array, and it should return false if every element is distinct. Hmm. So one very obvious way is using maps. Uh, that in case the map already has that element, then return true. Otherwise, when your loop ends, return false. But I'm thinking of a another solution. So a login solution, sorry, n login solution is sorting the array and then just iteratively checking if one element is same as the next. Just n square, which is what we're obviously not going to do. Sorting, it's n log n hash table, which is on. Oh, okay, so that's all that's given. Cool. So don't really need to solve this, as I already discussed. The solution is literally like a tiny solution. If it exists, return true. Otherwise, in the end, return false. It's not worth writing really. But now, how I find value and how much I owe for a clue. I'm not sure what you mean by that. Um, like what value are you looking for, and how much how much you owe who? Yeah, you can use this. How much do you have to pay who? You don't have to pay anybody anything, man. Just helping you out. You can just let others know about the channel if you like. Hope you got it. Okay. Contains duplicate given an array of integers and an integer k, find out whether there are two distinct indices I and j such that I equal to j and the absolute difference between I and j is at most k. Same thing again, just create a map and in the map store the index of the number, and when you find the number again, just check if the difference between that index and your current index is k or more. If it's more, just don't return anything. If it's not more than that, just return true, and in the end return false. Not gonna write this down. Yeah, this is what I was saying. Implement stack using queues. Why? Why? Okay, just one sec. Somebody's a question. I mean, but I need to find second value. For example, the second value is minus 50. Because minus 90, minus 50, then 12, etc. Oh, oh. Well, at the very least, you need to at least store all those values somehow. So, for example, okay, for um, let me just write the same code. Home for var I equals 0, I is less than, I don't know, equal to 5, plus plus, document dot write a. So you writing is just not enough. You also need to store these variables somewhere. Let's say you have another list. Let's say you have an array and list dot push a. Um, let let a be, say, I don't know, whatever your number is. I'm just putting it as I times 5. Uh, and put a here. Okay, sorry. Um, yeah. So you will have generated a list, and you have that list present with you here also. So you can just sort that list. Um, you should sort, you'll have to probably write your own sorting function. A comma b, return a minus b, I guess. Curly brackets, round brackets. Yeah, so that'll sort your array in increasing order, and then you can just get the second element like so. Okay. Anyway, right. You have to create a stack using queues. I just copied all that code and sent it to you. Okay, so I don't know how to do this. I'm just gonna try something. Push. If you have to push onto a stack, let's just try iq dot push. Push into the end of the queue, then pop. Remove the element from the top of the stack. iq dot empty. Hmm. Okay. Push. Pop. So you have to remove the last element. You can only remove the first element. So what do we do in that case? That's okay, man. Nobody is listening. Thank you very much. No problem. Um. Okay. Int pop. Bye bye. Sleeping. If I mute the mic, then no bye. Then you stay. Sorry about that. Yeah, so basically what I'm doing is I'm making a new queue where I'm adding all the existing elements except the last element. And I'll update top while popping with the last element that I pop from the stack. Yep, looks fine to me. Bracket mismatch at top. Conflicts with previous declaration. Maybe this variable. Top I, maybe. Let's just rename it. Has no member called peak. Okay, that looks like bad performance. Let's see what functions the queue has. Hmm. Who's at the front of the queue? Is that okay? Okay, that's cool. TP was not declared in the scope. What is TQ? Hmm. I think maybe you can use T uh, access last element. How do you pop though? Okay, let's just see. He has kept a queue and he's doing this. Yep, yep, yep. How's he doing q dot pop is just doesn't q dot pop remove the first element? Oh, so instead of pop taking time, you're making push take time. Okay. I guess whatever. I guess both's fine. Inverting a binary tree. By the way, you have a pleasant voice. Thanks, mate. That's honestly the first time I've heard that. Okay, invert a binary tree. Invert a binary tree. That looks very similar to what we did some time back, which was checking if the two that if the tree is a mirror, so all you have to do is replace the left node with the right node. So let's make a helper function that you send a node, and that helper function takes the node and auto temp equal to root left, root left equals root right, root right equals temp, and if root is null, return. Otherwise do this, and then do the same for the left node and the right node. So it doesn't matter if you do this before this or this way, it's not going to change anything. Uh, I'm from India. I think I'll have to update my description better. I'm from India and I am 25. I'm gonna turn 25 in less than a month. Yeah. Okay. Fairly straightforward. Let's just make sure that our solution, since it's recursive, it's going to take more time. But if you do it with BFS, it's going to take, sorry, it's going to take more memory. But if you do it with BFS, it's going to take not as much memory, but the maximum number of leaf nodes is n by 2. So at least less than ON stack, maybe. Actually, if it's DFS, it's going to be OH memory. Yeah, so worst case ON, of course. But yeah, I think it's fine. Let's see if someone's done something even better. I guess not. Cool. Um, Invert binary tree, power of 2. I've seen this somewhere before. Oh, it's getting cold, man. It's around 11 p.m. right now. Let me see if I can add a clock. So where was I? Given an integer, write a function to determine if it is a power of 2. Hmm. If n is equal to 1, return true. Now, one way is to keep multiplying the number, keep multiplying 2 till the numbers are equal, and the other option is that we convert our number to float, and while temp is equal to n, float of n, return true. If hmm, so temp divide temp by 2, divide n by 2, if temp is not equal to float of n, return false. If temp, if n is equal to 1, return true. Okay, this is log n, worst case. Output is true, and expected is false. I'd really like to see that in action. What? Why is that so? You're cheating with me, aren't you? That's weird. Then there's one other option. Uh, int temp is equal to 2, while temp is less than equal to n. If temp equals n, return true. temp time is equal to 2, return false. This doesn't look like a fast solution. Sign integer overflow. So just if temp to is greater than int underscore max, return false. Let's just look at the solution. Means one bit of n is 1. Oh, oh shite, mate. And wow, that is so clever. Uh, hmm. So basically, what it's saying is, uh, that n minus 1. Oh, okay, binary order of n minus 1. So if it's the power of 2, then it has only one bit, and if you do n minus 1, that'll have uh, too many bits. Only in that case will it be 0. And if that is 0, then your answer is true, otherwise it's false. Sweet. Sweet, pretty sweet. Alright, bye bye. I'm not getting any notification for these messages. Wish there was. Okay. To implement queues using stacks. using stacks. Okay. Stack st return stack dot empty. So stack you at the top and you remove from the top, but in queues you add to the top in stack dot push x. If in a pop you want to remove the first element. Peak is get the front element. Ah, int front stack int temp while st while not st dot empty, while stack's not empty, int top equal to st dot top, st dot pop, temp dot push top. Temp dot pop front equal to temp dot top while temp while not temp dot empty, return front temp. So basically I am pouring the stack onto another stack, so making upside down, then removing the topmost element, um, which removes the first bottommost in the stack, which means the first in the queue, and then pouring the stack back onto the original stack. st dot push temp dot top temp dot pop. Return. So what do you the removed element? Okay. Int ret. This return ret. Void value not ignored as it ought to be. Sorry. Cool. So you did push push peak. If st dot empty front equal to x. Yeah, because the first element of the push has to become the front. I think this is push one, push two. If push X. Oh, sorry, empty. My bad. All right, cool. That was fairly straightforward, especially given if you did implement stacks using queues. It's very similar to that. Push, pop, empty. Pointer points here. Stack.empty, front is X, pop, while stack is not empty, empty the stack, onto top, temp is pop, front is if not temp dot empty. I mean, it's sort of a corner case. Wow, best solution ever. Awesome. I see not a lot of people have attempted this question altogether, so probably that's why. Palindrome linked list. Check if a linked list is a palindrome, singly linked list. Could you do it in O n time and O1 space? If it's O1 space, it's without recursion. It's O n time. Okay, it's not. So basically, straight iterations. You could use 2 pointers if you like. Oh, so I think I've heard of one such solution. So you go to the end of the list. Actually not the end. You go, you find the length of the list. Then you go to the middle. Then you reverse the next half of the list, and then you start iterating from the opposite ends. It's a little too much to type, so I'll just show you the solution. Reversing a list is not considered O1 space. It is, mate. Reversed first half and second equal to second half. Phase 1, reverse the first half. Okay, same as the verb, but while comparing two halves, restore the list as the original. Yeah, okay. Like I said, it's fairly obvious. There's just, I think, only one way to do this. So we're gonna skip this as well. Lowest common ancestor of a binary tree. Okay, trees again. Lowest common ancestor of two nodes. Okay, so the simple list, the most straightforward answer would be um, if you find both nodes. So you're given the root, so look for both nodes on the left and on the right. So if you find both nodes in that node, um, then look for both nodes in its children. And as long as you keep finding it, well and good. And as soon as you don't find the last node that you looked in, the one before that is your common ancestor. So that is slow, given that you're looking for that node again and again till you actually find the lowest common ancestor. So if it's really down the height, you won't find it too very soon. What's another possible solution? I guess I've already told you the solution. So recursive approach, iterative approach, O(n) time, O(1) space. I like that. O(n) time, O(n) space, because it's recursion. The difference is hmm? How so? Uh, while node is not null, parent value is not a value. Is it BST? Oh, it's a BST, okay. If both P and Q are greater than the element, if both smaller, then else that's the node. That is fucking genius. Mind. Uh, Sorry for the language. Um, but yeah, that is pretty smart to not use space. And this was this is BST. I didn't read that, sorry. Yeah, then it becomes even simpler. You don't have to repeatedly look for anything. Again, really no point writing. It's 4 lines of code. Delete node and linked list. Only access that node. Yeah, so this one is I was also asked this recently in an interview. So how you do it is so node is stored at some address, the reference to this node, whatever is pointing to this node. So at the address of this node, we set if the syntax is right, it's gonna work. L value required as left operand of what? This is storing some address. So now at this address, we're going to be storing this value. Hmm. I'm not sure of the syntax now. Um, this, so say A is pointing to this node, and the address stored in A is of this node. So what if you replace the address stored in A with something else, which means the address of this node is replaced by the address of the next node. L value required as left operator assignment. Huh? Hmm. Let's just look at the answer. Um, no, without copying the value. Oh, it's star. Okay. So the pointer pointing to the node now points at the next node. Okay. Uh, Obviously the interviewer doesn't want you to change values, so why he's asking you to do this and not what? Determine if one is the anagram of another. Huh. Mm-hmm. So one way is creating a map for the first one and inserting count of each occurrence on the map, and then for the other string we find whether or not you whether or not that item is in the map. If it is, reduce the count by 1, and if it is and the count is already 0, then it fails. What if the inputs contain Unicode character? How do you adapt your situation to such case? Okay, one's obviously sorting, which is much slower, but no space. Hash table. Oh, so I guess hash table was the answer. Cool. So I guess if it's again, we've done many similar questions like this. I'm not looking for the solution. I'm just looking for the next question, man. Shortest word distance. Oh, okay, some are logged questions. Sorry. Anyway, there's nobody viewing stream right now. So I guess I'll be logging off for today. Um, it's almost 12 p.m. What am I gonna do after logging off? Nothing really. I haven't checked my phone in a while. Yeah, I am checking my phone while streaming. Hmm. Binary tree paths. Given a binary tree, return all root to leaf paths. Just 2 DFS, man. Keep a string while going through DFS and add your current node to the string, and then when current node is null, push that string into your result, and you're done. Again, really not a question worth it. Your result is passed by a reference. When you get to null, you add it and you're done. Otherwise, for each left and right, you recursively call this function while adding your current. Yeah, there's no point really doing this question. Like if it's very similar to something we've already done, say multiple times, then there's literally no point. A very downward question, add digits. Given an honor, repeatedly add all its digits until the digit has only one result. While num is greater than 10, int temp equal to 0, while, I don't know while what, while num is greater than 0, temp plus equal to num %10, num equal to temp, return num. I don't know why this question is even there. I'm pretty sure all the comments are it says Could you do it without any loop recursion in O1 runtime? That's a good question. Um, O1. Um, Maybe thinking in terms of bit manipulation, maybe. But even then, you have to do it sometimes, right? I can't. Um, Asshole. Sorry. My bad, actually. Let's see what people say. O1's time, O1 space. Holy mother of God. Okay, so this is something that you would have noticed only in case it was a peculiar example. So, basically what happens is, when you take any multiple of 9, it boils down to adding up to 9 always. Um, so they've kind of used that as a trick, saying that divide the number by 9. So basically remove uh, all factors of 9 that it has, and so just subtract 1 from the number, then remove all factors of 9 that it has, because removing 9 from a number does not change the sum of its digits. So like say 12, okay, bad example. 32. 32 minus 9 is 21. Sorry, it's 23. Minus 9 is 14. So it happens so because when you say remove 10, you remove 1 from the first digit. But when you remove 9, you remove 1 from the first digit and add 1 to the second digit. So the sum of the total thing remains the same. Holy hell, Lord. That's genius AF. Percent 9. So now if you do that directly, you will lose all numbers that are 9. So for numbers that are 9, you do this instead. Beautiful, man. That's beautiful. Awesome, man. I think we'll stop here for today. It's getting late, and we have covered quite a bit. today. I think yesterday we stopped around 30 questions, including 9 that we done earlier, maybe or not, and we ended at 60. Anyway, um, it's around another 30 questions today. It was a weekday, so it was slow also. Probably would get better with time. Hmm. Then there are so many questions. Let's just check how many medium questions there are. If we switch to medium, what's it gonna look like? There's even more. Are you kidding me? There's many more? So there is 6 times 630 or so medium questions. It's too hard. Not too many. Under 300. Maybe like 250. Yeah, they're too hard. Oh, wow. Hmm. Okay, so it was easy Monday. Uh, See, problem with medium is it's gonna take more time. But the problem with easy is that they're not gonna be used that much. And they're generally easy, so you'll probably be able to figure them out without really much practice or anything. So without any loop recursion, yeah. Not without any loop, but like if the sum of digits is divisible by 3, if it's power of 3. Oh, hmm, hmm. Return if n equals 1 or n equals 3, return true. Else return n percent 3 equals 0. Oh, then it's only a factor of 3. Hmm. 27. Expected true, which means true or is equal to 0 or is equal to 9. Output is true. If n is equal to 0, return false. Output was true, expected was false. Factor of 9 and not of 3. Okay, I guess I don't know. Hmm. Give us a root, loop, base conversion. Huh? Okay. Mathematics. Hmm. If and only if I is an integer. Hmm. It is a factor of 3 only and only if it is completely able to divide the highest number of things available. Hmm. Cool, yeah. Awesome. So I'll take a leave, guys. My bot and myself, that is. Um, Sorry, I wasn't looking at chat. Wait. Um, document dot write. Oh, let me just PM you. Document dot write list one. I think that should work. All right, I'm taking off. Long 2.5 hour stream. It was fun. I have a feeling that I think doing easy problems is not really gonna up our game as much. We could pick up the, less accepted easy on questions like these ones. These ones. Yeah, I think beyond 40 is sort of easy. Looks. Yeah, let's just pick these ones tomorrow, and then uh, on Wednesday we're gonna start with medium. Yeah, cool. See you guys. Bye.